And as stated in the previous video, I successfully calculated the expected returns, variances, and covariances using the Markowitz approach. And if you're considering 6,600 investments for the portfolio, you must calculate the same number of expected returns as well as the same number of variances. However, for the covariances, I calculated this number by taking the quantity of n squared, or n in this case is 6,600. So I took the quantity of n squared minus n and divided that number by 2. And so the success of the portfolio selection rule really depends on the quality of the input list, which is the estimates of the expected security returns and the covariance matrix. And using the Markowitz approach is pretty much a formidable task, and the Markowitz model may lead to a great deal of errors in estimating the coefficients because of the large parameters. But in contrast, the single factor method greatly reduces the number of parameters to estimate. And therefore, for the expected returns for the single index model, the investor must calculate the, or rather, must add 1 to each of the factor variances and the factor risk premium. And so therefore, after you add 1, which is demonstrated in the table in our class notes, chapter 8, page number 3. I just misread the lines, or those 2 rows, And so for the final answer, under the single index model, the investor would calculate the 6,601 expected returns as well as 6,601 variances, because once again you have to add 1 to both of these numbers for the factor variance as well as the factor risk premium.